Hi, hello. So we are about to do the third part. I hope that it's going to be the last part because this is quite a hefty one. So we're going to talk about how to make the controllers and how to copy the controllers onto the master rig, and we'll talk about also sticky controllers in the second part of the video and how to actually make a sticky controller. So, what are we gonna do first? We're gonna first try and draw a bit on Krita so that you can sort of understand what we will do in the video, basically. So now, what we have is we have plenty of rigs. We have plenty of rigs that are already done here. Inside of the viewport, you'll see. And then all these rigs have their blend shape transferred to this one, and then this one transfers all the blend shape to this one, and also this one transfers blend shape to this one, because blend shapes are here to transfer the shapes of the things. But thing is, an animator, when an animator is animating, when an animator is animating a character, he's animating on this mesh. And he wouldn't, as an animator, he wouldn't spend the time to going back and forth between all the individual rigs just to move, for example, a bit the lips, or a bit the eyebrows, or maybe just a bit the lattice and all that. No, he won't do that. We, as riggers, we need to make the life of the animator a bit easier, thanks to all the tools that were given to. And so that's why we need to copy all the individual controllers onto this mesh, and then after that, the coordinate, for example, the translation, rotation, and scale data of all the controllers that are copied in here will be transferred back to those controllers. So that means that all the controllers here would be immovable. Like, they wouldn't be able to. We wouldn't be able to move them on themselves. We will constrain all the controllers that are going to be on the master rig. We're gonna transfer all the translation, rotation data, and scale data onto the individual rigs once we had copied every single controller. So there's that. And in the second part, we'll see a little issue that we will resolve in the same video. And I hope, let me just time myself, because I don't want this video to be 1 hour long again. So yeah. We're gonna jump into Maya. I'm gonna close that. Yeah, let's go. And now all we have to do is to copy every single controller. So in our case, we don't have that much amount of controllers, fortunately for us. Controller rigs. But this one is okay. I've made a grave mistake, but okay. I forgot to make a sort of an offset group on this one, and you should never make a controller without an offset group, because at the end the animator will always use a tool to reset the controllers, and if the default position of a controller is not 0 0 0 0 0 and 1 1 1 on scale, then it will reset the controller in a weird way. So that's why we've got those kind of things. So we've got this controller. I'm just going to rename that correctly. What I wanted to tell you also in this video is a certain method that enables you to copy every single controller within a rig that is other than the main rig, the master rig. Copy all those controllers and reposition them right on the right spot, inside of the master rig. So that method is that first you need to place in the right way. You need to place in the right way the offset of the transform of these things, because how can I tell that? We need to have a transform. We need to have a transform that we need. This is hard to explain. God damn. We have to. We need to. Have a transform here, a position, a pivot that matches this, but relative to the other rigs. So basically, for example, you have, the arrows in here. You have, for example, the origin of the world that is right here, and even the origin of the mesh. You can base your thing on the origin of the mesh. So in our case, the origin of the mesh is a bit well, it's in the origin of the world, but it's going to be the same thing. So you can have all the groups here. For example, group lips. I can reposition the transform, the pivot onto the pivot of the mesh, because you know that this won't move, and this is dependent. Like the position of those controllers depend on the mesh. So that's why all, for example, the group rigs, the group rig lips here, we can export everything. We can unparent every single thing inside of the lips rig, and then we can match transform the group lips rig to the mesh. So we won't do that. No. So here, match all transform. Here we have a group that is set in the right way. And then we can reparent everything together. Okay. All right. Technical issue is going to be resolved by unlocking. So that's why. The reason why it did that is that I already had a mesh that was the NRB surface that had its coordinate locked, and so since we're moving the origin point of the parent group here, the NRB's lips want to stay at the same place. So we need to Control Z everything, and then we need to unlock. So first, I'm gonna do this. We need to unlock the parameters of this. So copy scale, no, we want to unlock selected, and then we will be able to reparent everything. So for example, if you have the mesh here that is skinned, or if you have another thing that is skinned that needs to that is bugging out whenever you're changing the pivot of the parent group, then you might just need to unlock all those parameters, and then if we do this, normally it should be fine, and it is fine. It is fine. And now you see that, translate y is at minus 43.944, and that's totally normal, because when we created the rig, we had the pivot point of the lips on the origin of our scene. So that's why we have this. We can lock everything back again. So lock selected. Also, even though you haven't locked manually, if you haven't locked manually, this happens whenever you bind skin something with something else. It always locks the parameters of that object that you skinning joins to. So now we have the pivot that is all set in the right way. let's say, yeah, it's good. It's good. And now we can have also, so those, we can have something that is called, I mean, like we can make a group that contains all the controllers of the rig. So group controller lips. And now we can copy everything. We can copy everything, put it inside of the word, or no, we don't need to do that. We can copy it and then match transform this, match transform with this, and normally we have the thing set up correctly. Magical, isn't it? We need just to move everything around in the right way, and also a pretty easy way to have the controllers following the head is to parent every single controller that you selected into the controller head, so that whenever you move the head, the controller moves also. The controller moves also here. Okay, all right. So we have this one, and now we can rename everything inside of the rig proxy. We can like rename it in another way. So that because right now we have all those things that have the same that have the oh, that's weird. Huh. I thought I had it in the group mesh. Simple. Huh. Okay. That's why it was a bit buggy. Okay. Now, yeah, now it's working. Okay. So yeah, we have a lot of things that have the same name, and we want absolutely to not have the same name on the rig, whether it is another well, hierarchy. We don't want to have the same name, so that's why I like to put everything with proxy afterwards. You can like put a dollar. So this tool is called search and replace names here. And so you can put a dollar sign, and so basically it will it will add the line afterwards to the end of every single name that you selected. So now I need to select, and now you put it the thing in the hierarchy, and then everything is in proxy with proxy at the end, and we don't have the same name in the true control hierarchy and the false control. It's not really the false control, but yeah, I think you get what I mean. All right, we have this, and now what we need to do is to link the controller of the controller of the origin rig, the master rig, to the controller here, so that the animator can directly go here and animate this, and it will react in the way that we want to with this one. Okay. So now we have to go in the node editor, our good buddy node editor. So we just need to have all the transformation. So those are the things. 3 to unhide everything from these controllers, even though they have still some things to show. And then that's proxy. Those are proxy, so you know that they need to be piloted by, they need to be constrained by the control lips. So here, let's unhide this. Lips 1. So lips 1, it's this one. You just link, translate, and rotate, and scale. Sometime you can, if you want to transfer all the data, you can even like just transfer the scale if you want to. But it really depends. It really depends. No. I want to have rotate going inside of rotate and translate going inside of translate. Okay. Now, if we check our rig, aha, I forgot. I forgot to tell you. Yeah, I forgot to tell you about this little issue that I had on my rig. So shape editor, the method that I used, before with two, if I have two blend shapes going inside of this, one blend shape is gonna overlap the other blend shape. So what I mean by that is that, for example, we have the blend shape here that is working all right, but if we deactivate the blend shape that transferred this to this, if we deactivate that, this should work. Yes, it works. It works. And that's why, like, the blend shapes are overwriting themselves. Like if I put half and half, you can see that it's sort of working all right. But we have half and half the transfer deformation of both worlds. So that's why I said inside of the other video, the precedent video, that you can transfer, if you have this problem, you can transfer the blend shapes via blend shape. You can transfer the deformation from here to here, so that you don't have this problem, and at the end you only have one blend shape going between these two. So I'm gonna delete that one. I think, yeah, I can delete that one, or maybe I can even move it potentially. Rig buffer blend shape. So here, no, I can't move it between the two. So here I'm just gonna put a blend shape over here. So no, I'm dumb. Can just gathered rigs. So this is a rig gathered blend shape. Yeah, so that's this one, and I just create target. Yeah, you can see that now. Now the rig is picking up the blend shape thingy. So yeah, it's doing this, and you can also deform the mesh like this. Perfect. Now you see more or less the basis of, the basis of how to transfer the sort of data of the controllers from here to the individual rigs. So now we'll do this. We'll do this for this one. So now we want to have. Okay. I think group lattice. Okay. Yeah. Okay. Offset lattice. So this one needs to, I can directly say, yeah, just the work that I've done is not really nice. So controls lattice here. I can ungroup everything. I can match transform this to this. So match transform goes into match transform. Now we have the group controls lattice that corresponds to the transform of the mesh, and then you reparent everything together. You copy the controls group, and then you match this group to the other mesh, this copied group to the other mesh, and this will match everything correctly or accordingly. Now you need to delete the joints. You need to delete the joints. Move this into another part of the hierarchy that is more adapted to it. So here I need to rename also. I need to rename the proxy, well, I need to rename the controls that I'm not handling myself. So again, search and replace. I just like put the $sign here, and then this is going to be the string that is going to be added to every single name. I just hit apply, and you can see that the proxy name had appeared on every single subgroups compared to then every single children. Okay, all right. We have this. This doesn't move anything, and we're gonna fix that by doing this. I think I can even search and replace. No, it's not search and no, it's not search and replace. It's node editor I need. So I need to connect that. Yeah. Okay. Pin clear, and now we'll see who's the proxy. So that's not the proxy. This translate to rotate. Well, what am I saying? And now we should be able to manipulate this from the master rig. And you would say at this point, by this point, you would say that, oh, but the rig is finished and all that. No, it's not. Because you see that whenever you're removing the controllers in a certain way, and whenever you're deforming the mesh in a certain way, the controllers don't follow the mesh. They don't follow the mesh. That's a big problem. Whenever it's a big problem, certainly, most certainly when you have a deformation that hides some controllers, and that can be really annoying for animators because they will be obligated to move a controller to access some other controller, and they can't do that because they need to key. They need to key this one correctly. And so it's really annoying to not be able to have a grasp of every single controller. So that's why we need sticky controllers. Okay, but what are sticky controllers? Okay, now it's gonna be the interesting part. 20 minutes? 20 minutes is fine. I think I'm gonna make myself a drink. Yeah. All right. Hello. So I got myself some drinks. Okay. So something that I just forgot to tell you, and I forgot to do, is to have controllers inside of the viewport that controls the blend shapes, because right now we don't have anything that controls the eyebrows. So what we want to have is a line to define. I think I can model a line. Let me do a line. No, I don't want to. Don't want to see anything. We can go into create. We'll create just a controller like this. I think we can put it in linear here. Activate this so that we do a straight line. It's not drawing, but it is there. And if we do this, we have a straight line. Okay. So now, if we put that in perspective, I need to make sort of a group like this. Okay, so curve 1, this one will be the controller eyebrow R. Why not? And this one is going to be the offset of the eyebrow R. And then I can use it's almost unusable. I mean, like, it's not really optimized, but you can use basically this tool to rename a whole node tree. Well, it's not a node tree, but a whole hierarchy in one go, and you can transform all the R into L's, and it works like this, and now we have two controllers. But we want to have those controllers. Wait, I'm gonna put those controllers in the right place. So I'm just gonna move there, snap to the point. I'll just click on that so that it snaps to the points, to the actual points. I think I'm gonna put it here. Alright, so if I go there, I can just cancel this position. I need to also cancel all the deformation happening on the transform. It's always better to make the controllers on the mesh that is not deformed. And even there I can just, for example, this R is gonna go on there, and L is gonna go on there also. I can then afterwards just bring them a bit more in this direction, or even sometimes it's much more handy to just it's much more handy to let the pivot of the offset right on a vertex, because you'll see with the this method. So here I'm gonna do a multiply by 1. Okay, it's still doing that. So oh yeah, I forgot to save. God, this is bad. Now I'm gonna put the clamp. I'm gonna do exactly the same thing. -1. Because whenever the controller is aiming towards, is like translated in the y direction towards -1, this coordinate y is multiplied by -1. So instead of approaching -1, instead of the value approaching -1, it's gonna make the value approach the 1 value, and then if we clamp that, it won't go over the 1 value, and it won't go below the 0 also, because we set it up those ones here. And so now if we use the green one, so that's the R, R here, R there. Okay, and now if we are doing this, this should work. Yes, this perfectly works. And we can even like make him have only one eyebrow going up. Okay, and I'm gonna use one of my tools to color this in the right way. Now it's shiny, it's beautiful, and look at it, nice controllers. And now we have the head, but again we have the problem of the controls getting totally hidden inside of the head, because the controllers don't follow the mesh, and so that's why we need to use sticky controllers. So the principle of a sticky controller here is to have the opportunity to have every single controller following the mesh. So that's an example. That's my rig that I'm gonna soon publish, and we want to have every single controller stuck to the surface of the mesh here. And thanks to this little thing, you can have a lot of you can have all these controllers on the skin, and no controllers will be hidden. Well, almost none. Most of the controllers will follow the mesh, and even if the mesh is disformed like this, you will still be able to do those kind of things. But for doing those kind of things, you have to make those shapes, those controllers, stick to the surface of the mesh here. And that's the hard part. that's the hard part. It's to make this constraint that enables you to stick sort of a transform on the surface of a mesh. So in this video, we'll talk about how to do that with UV pin. We'll talk about how to do that with a UV pin. Because UV pin is generally a method that is more reliable because it can make you pin a controller on every single part of the mesh, and it doesn't have to be right on the vertex. Like it doesn't bind it to a vertex particularly. It binds to the surface. So even though the closest point of a mesh to a controller is, for example, the middle of a face, the UV pin will still be able to constrain that controller to the surface of the mesh. So I think I made myself clear. It's quite weird, but unfortunately, I can't see the people that see me. That are listening to me. It's quite weird. So I think I was clear enough on that. So what we want to do right now is to open up a new scene. So that's why I opened up this. I want to make you practice on another. No, that's just script. No, thanks. What we want to do is to exercise on this. So you create a sphere, and then you just delete history because you don't want to have that. And so UV pin. UV pin is a method that uses the UV to pin an object to the surface. So that's why you need to have your UV done before actually rigging on the mesh. So what we need to do right now is to go and create a new controller. We want to have a controller. So what the stages? What are the stages of creation of a sticky controller for those who want to directly script? So what are the stage? Here are the stages. So you can take a screenshot and try to figure out by your own self before I actually show how to do it. And you can begin already writing a script that can sort of do all these steps. And good luck. Good luck with that. On to past me. So now we have to do those kind of things. So I just need to cancel that. So we'll first find the U and V coordinate of the closest point to the controller. So medium plus. We'll have sort of a controller here, blue pencil. No, we don't want to have that. Okay, so that's that. I'm just gonna resize the controller so that the controller is not too big. And now we have this controller. All right, I'm gonna move the controller like this. You'll see why. So now we need to jump into, if you have the controller and if you have that also, you need to jump into the node editor. And so that's going to be there's going to be some few stuff in the node editor that you're going to need to do. So you need to take the shape of the mesh that you want to bind the controller to, and you create the node point closest point on mesh, that one. Okay, so now this doesn't show all the attributes, so you need to hold right click, show all attributes here, and then you'd have to put the out mesh into the in mesh here. And now you grab the, I should get rid of everything. You should grab the default name well, you should grab the controller, the transform of the controller, and put this in the position. Okay, and what does that do? That's a good question. That's a really good question. You'll see that if we go into the attribute editor, let me see, result. Ah, we have some things. We have some things that are a bit interesting. You see that we have a U and a V parameter, which is quite important. And we can see that whenever we change the position of the controller, the U and V coordinates are changing. And that's totally normal. That's totally normal. And we should, and so inside of the script, you should take those two parameters and put it inside of the UV pin that we're going to create afterwards. So now we have to create the UV pin. So before actually creating the UV pin, I always like to create this locator. Because it enables us to see the position of the UV pin in function of the controller. So you need to create a UV pin. You need to create a UV pin. I think I need to do this. You need to select a vertex and select the object that you want to constrain to the surface, and then go into constrain, and then UV pin. So if you go in on the window here, you can choose new transform, existing transform. Personally, I prefer to have a new transform because it enables me to have more flexibility, and yes, it creates a new group inside of the node editor, but at least I can use that. I can use that new group for my advantage, and even sometime I like to mix matrices between two UV pin groups. So if I click on apply, now it is working more or less. And if I put this and I reset the controller here, we can see that the locator is constrained to the surface. Okay, the locator is constrained to the surface, but not in the right spot. Not in the right spot. It's not giving us the closest position on the mesh, on the surface of the mesh. Actually, right now. So what we need to do is for our friends that like script, that likes scripting, we can. I'm gonna just pin everything. You can directly inject the parameters from the closest point. So if you go here, results, you can directly put. Oh, yeah. So that's the UV pin. You can inject the coordinates of resulted from the closest point on mesh into the coordinates of UV pin 1, and so now you will be able to see hopefully, aha, it works. And now you can see that whenever I move the controller, it finds the closest point on the surface of the mesh. It works. It works all right. But there's one problem. We used the problem comes from the fact that whenever we we've put node editor. Okay, node editor. We used the in position on the closest point. So in position, we put the translate here, and the translate is only valid in the local space. How can I tell that? Well, the closest point was working because the pivot of the controller was matching the pivot of the mesh. And so that's why whenever I moved my controller, it matched. It matched correctly. But what happens whenever I do I move the offset like I would in a normal rig? Then it doesn't follow. Ah, okay, it doesn't follow. Ah, and if I put this at 0, it goes a bit wonky. It goes a bit wonky. You see, it's just like, and it's normal because like the position here is 0. So since that is a circle and every single surface is more or less as close as it could get to the center of to the center of the object, of course it jumps around because like you have a controller that is like inside it trying to find the closest point, but it's not actually the closest point. And how do you resolve it? So how do you resolve it? You can resolve it by instead of using, so that's something I could do. Instead of using the translate of your controller, you can use the world matrix and export the translate of your world matrix from your controller. And so if I go there and I just do a decompose matrix, press on 3, so world matrix, here, translate, and there, and if I do this, this works in the right way. Yeah, it works. It works. It works. Now, if I move the controller, it works, and if I move the offset, it works also. So everything works except, haha, this only works. This only works because the translate is the pivot. How can I say that? This only works because the mesh of the sphere is at the center of the world. It's at the center of the world, so the local position of the sphere is matching the translate of the world. I don't know if I think I lost some people, but yeah. So the symptom of having like not yeah, how can I? This is really complicated. Symptoms of this error that you might encounter is that whenever you move the sphere, it doesn't really care. It doesn't really care. It's like it's ignoring the translate of the sphere, so the mesh. So what you really want to have is the translate relative to like the translation relative to one another. So that's why you need to take the world matrix of this one, take the world matrix of this one and subtract it by the world matrix of this one, so that you get the relative matrix between the mesh and the controller. So how are we going to do that? We're going to use a mult matrix. So if we go into the node editor here, we're going to use a mult matrix. And I need the transform of this. I need the transform. Okay. I have the transform. Okay, I have the transform of the mesh, and then mult matrix. Okay, so we need to have the world matrix of the controller, and you multiply by the inverse matrix of the transform of the mesh. And then if we plug that in here, it works. It works. And it even works whenever you're doing that, whenever you're um, you're whenever you're rotating the sphere, it works. It all works. You can even like just amuse yourself and make a spike here. If you do the spike, it will sort of do this, and it's just mesmerizing. I don't know. There's something about that that is mesmerizing. But how do you pin the controller to the pin out? Well, how do you pin the controller to the surface of the mesh? Ah, good question. Well, that's where you need to sort of memorize inside of your node editor. You need to sort of store somewhere the closest point on mesh parameter u and v, so that it still remembers where the controller is. Because you want to break the link. You want to break the link between the controller and the UV pin right now. Because at the end you want the UV pin to guide the position of the controller. So what you will do is that you're going to delete the point on mesh. Now this should be, yeah, I think so. I'm just going to control Z on everything. I'm going to reset those things here. Okay. Offset, so this is offset. Okay, and now I can, so just remember this position. You can delete that one, and you can see that the coordinates are still remembered by the computer. If I can manage to coordinates, Sometimes the UV pin doesn't want to work, and that's alright. You have to live with it. You have to figure out what is the problem. By your own hands. Oh, now it works. Okay. So, yeah, the little problem that I encountered was the coordinate at 0 here. That was basically at the UV pen likes to only use the coordinate 0 here. So if you have coordinate 1 and you inputted some few coordinates into coordinate 1, it won't work because it will give the priority to coordinate 0, which it doesn't exist. If you have only 1 and not 0. So now it works, and we can parent everything to the pin out. Okay. Yay! Yay! It's working. So you can have something like this, or what you can do is that you can have a group constraint. So if we go into there, control constraint default name. So we have another group under it, and we can have a constraint or a point constraint or a parent constraint, whatever you want to. It's up to you right now. Yeah, I mean, can do whatever you want to. And now we have the point constraint. If you maintain offset, you can see that the point is respected. That's weird. Oh no, that's not weird, because if we reset that, here, yeah, I should delete that one also. I should delete that one. So if I put that on the, it keeps the offset. It keeps the offset. That's just that. So we just apply this, and you can see that it is following the surface of the thing. Really funny, huh? Really funny. I see your game. I see your game. But you get the point. You get the point. Come on, man. Just work. Oh yeah, that it doesn't work because yeah, it's yeah. Just move it. Just move it. I mean, I guess I can just like put it. Match transform. There you go. There you go. Now it should be better. It should be. Should be. Can match transform here to here also, or maybe no. I'm gonna match transform this to this, and then if we have a point constraint, then inside of our rig we'll mainly use the point constraint. Because we don't really want to replicate the rotation of the mesh. Sometimes if you have a lip, so let me give the example. Sometimes if you have a lip, you sometimes want to have the follow rotation of that, but in most of the cases you don't really want to match the rotation, because if I match the rotation, for example, on this controller, I will only my controller will like enter the mesh, and you only want to constrain the position when you want to put the controller onto the mesh. Don't really want to do anything like this. So yeah, all right. I hope you got everything, and now we're gonna do the same thing on the rig. On the rig, let's do it. We can quit this file. Here, okay. So I have everything. Let me see. Yes, I have this. Okay, all right. I think we're gonna first pin that. So we're gonna first pin this one to this one. So like before, we import on the node editor the transform of the controller, and then we import both the shape and transform of the mesh that we want to pin the thing on. Okay, so now we have to put the closest point. No, not closest point. Closest point on mesh. 3, press on 3, but also show all attributes. Just like in the node tree, we need to play with the world matrix. But in our case, the mesh is at the center of the world. So we don't really need to play with the world matrix. We can just directly convert the world matrix of the transform of the controller into the translate. We can put the translate of the decomp into the in position. But we need to have the mesh. We need to have the mesh of the subject inside of the closest point. And now we should obtain in the it's inside of that also. Yeah, we should obtain those two numbers. So those two numbers, you're gonna remember them. You can even Control C, Control V, but separately we're gonna have to yeah, I think I'm gonna do a block note. I'm just gonna write something. I'm gonna write down the coordinates. Please, would you just copy the thing? Copy. Thank you. copy, and then there you go, because those numbers will be modified since we need to sort of move the constraint. So that's we need to add the constraint group to parent the main thing, the main controller to constraint controller, and now we select the a vertex of the mesh and then the constraint group afterwards, and now we create the UV pin here, and now we click on apply, and now we should have a little pin out here. So we can rename this pin out lattice. This can go in the useless sort of the group inside of which you can put a lot of stuff that are not important in MISCs, because at the end you will use a point constraint to constrain the oh, it's so tiring. To constrain the I can't speak. To constrain the the constrained group of the controller to this via point constraint. I hope you all understand. So we have this one that is not really that important. We just need to put in the coordinate zeros. So coordinates 0 here. So we need to put in the coordinates that are the most important. I just okay, and now we have to delete where's the node editor? I just got rid of it. We need to delete that because we don't need that, because we only needed that closest point on mesh to calculate the closest the coordinates of the closest point on the mesh, so we can delete that. We have everything. Okay. And now we can constrain the lattice. So we'll do this. We'll constrain the constraint group of the controller. So we can select this and this. Okay. Constrained, point constraint, and you need to maintain offset. All right. Good. Goody. And if we move the mesh, so we'll unlock those. We just need to verify that it works, and it indeed works. You can see that the lattice is binded to the position of the mesh, which is great, which is totally great. So we need to lock selected. We need to lock the attributes of the mesh that needs to be constrained. And now we will sort of like the animator will sort of do the things, but you will see that we have a double transform. And so that can be solved with a group that compensates for the translation of this controller here. So you can create another group inside of the constraint group that is called compensate compensate lattice. And now inside of the node editor, we are gonna put this in here. Delete the well, it's not delete the shape. And now we need to say that okay, the translate here needs to be compensated with this group. So basically, we need this group to do the inverse transform, the inverse translate of this one, of the controller. We will do that with a multiply divide. It's really simple. Like on the node editor, it's really simple, but theoretically, it's quite complicated to grasp why we need all these things. We just need to multiply divide, set all the second input to -1 to invert. Okay, OBS just cut my little recording, so we have put every single parameter on the second input to -1 to invert the translate, and then we apply the translate here, and then you will see that it does work. It does work. Aha! It moves. It moves, and it only moves because of the mesh. If the mesh doesn't move, so let me demonstrate. I'll just try and see everything. So if I disconnect this, if the controller here is not connected to the controller up there, you wouldn't be able to move this, which is totally normal because you have a group that compensate for the translation right up above. So that's why in some cases you might say help because it moves. It doesn't move, and it shouldn't be normal that it doesn't move. But don't worry, it's normal. It's normal. It only moves whenever you connect the controller of the master controller to the controller in the rig, and now it moves. Now it moves because the mesh move. All right. Everything understood? I hope that everybody understood the concept. So we have this, and you can see that everything follows accordingly. Yay! Now let's do the same thing with the other controllers. So you can have a script that can directly do this. And now if I put this into there, and I put there, and then and now it's all set and done. And you can see that if you do this for the other controllers, so here let me point out again, I used a script that I scripted myself that enables me to bind all the controllers to the mesh that I selected last, and so now we can sort of move this around, and now you can even do that for like Blendshapes controllers. You can do that with Blendshapes controller. And if we do this, you can see that you can move the controller like this, and it all works. It all works. It's all right. I mean, yeah. And now you can finally have a rigging, like a face that is correctly rigged. And that's basically how you do a facial rig in the grand lines, because I only scratched the surface of facial rigging. I only scratched the surface, and there's many more things to learn about facial rigging. In fact, I believe, from my point of view, facial rigging is the hardest type of rigging. From my experience, which is almost none because I only went into an art school, 3 art school, so uh, I can't really tell if it is the hardest. I think potentially muscle rigs are even harder than facial rig, but still, like, if you compare body rig with facial rig is a lot harder, and it's not only because of those simple things that I try to enunciate with you, that I try to explain to you right now. It's also about all the other stuff that you're gonna tackle, all the other problems of, oh, how do you rig an eyelid? Oh, well, good question. Go figure out, but it's complicated. It's all complicated. So yeah, I hope this tutorial will enable you to make some sort of a rig, and I wish you good luck on your personal project or on your yeah, on everything related to facial rig. And I hope that I was clear enough on all the things that I talked about inside of the video. And I'm sorry again. I'm sorry again for my English, and I'm sorry again for not being as clear as possible. I hope I was clear enough. Yeah, I sure hope I'm clear enough. So yeah, just you can ask me some question on the comments, and you can just, yeah, I don't know. I'm not a YouTuber, but like, it's just having comments is nice. Yeah. But yeah, I wish you all good luck, and bye bye. I hope I was helpful. Bye.